Greetings. This is episode 6 in the ongoing series on the Seeed Studio Chow starter kit and its sensors and modules. So here we have the starter kit board, and in this episode we're going to be using the real-time clock, which is that chip here, and we're going to be accessing the internet. Hence there's a little antenna connected that came with it. This antenna seems to work reasonably well. In actual fact, it's double-sided. It's got sticky tape on there, so if you put this in a little box, then you can stick it to the side of a box. I also could have used any one of these antennas that I have laying around, but it doesn't seem to need it. It's good enough as it is. And this is the temperature and humidity sensor module that we're going to be using. And if I hold it just the right way, you will see it has, this one's a little different than some of the others we've used. This has 4 connections: SCL, SDA, VCC, and ground. And the SCL and SDA, of course, tells you that this is an I2C module. And these 2 ports over here, it'll be a little hard to see. It's small, but it says SCL pin 5 and SDA pin 4, I think it is, yes, onto those. So these sockets here are compatible with that module, so that's why we plugged it into there. And if I turn it on, take that away. Okay, it's initializing, it's accessing the Wi-Fi, and it's done it, and it's found the time. It's currently the 23rd of October 2024. It is 11:01, nearly 11:02 a.m. and the temperature is 20.9594 degrees. Humidity is 42 something percent. So it is all working quite nicely. So let's have a look at the code. Alright, so we're in Platform IO. Later on we'll try something in Arduino, for those of you that are interested in the Arduino IDE. So what we have here is, therefore, we're using our ESP32C3 module. Seems to be quite a robust, and it's one of the cheaper ones that the Chow people make. So seems to do the job. There will be no difference if I use one of the others. I can change this to S3 and it would work just the same. The S3 module is a little bit faster than this one, I think, but for this purpose here, we are not worried about that. Okay, so we have 2 libraries that we are using. The OLED display, we're using the UHG2 from Ollie Krauss, and we are using the NTP client library for accessing the NTP server. They get the current time and date via the internet, so we can set the real-time clock chip. That real-time clock chip, of course, has a little battery underneath the board, but I have not placed a battery in there, so, and nor does it really need it. Every time you turn it on, you can just get the time and date from the internet, and you can update that once a day or once every hour, whatever you would suit you. So I see little use for putting that little battery in there in this case. In any case, we have the main code over here, and it is similar for one that we've done before, but this time we have included a file, DTHT. I sourced that from the internet, and it is actually in the include folder here. I put a DHTH, and in the source folder there is an DHTCPP. This actually was a library that is done by Adafruit, but when I'm using modules, this is not an Adafruit module. I may have to make some minor changes to it or something in some cases. So I'm in the habit of grabbing the actual files out of the library and just sticking them in my own project. That way I don't need to include the library, and if there's any updates to it done in future or something, I can look those over and actually either re-import the file or I can actually edit it. But the idea is here it's working perfectly, so why would you ever want to change it? So it's safe in my own project here, and I prefer to do that sometimes. And I've done the same thing with the PCF 8563, that's the real-time clock module. We did another episode on that, so I'm not going to go into that into a great detail in this episode. And back to our main code. So therefore we have, the usual requisite Arduino, the UHG2 lib for the OLED display. We call in standard header files that are available both in the Arduino and the Platform.io system, the time.h, so that we have time-based functions, real-time clock, as I said. This is the humidity temperature library, and we will be accessing Wi-Fi. So these are all sort of standard includes that you do for that. And the DHT library can actually support different types of modules. This happens to be a DHT20. So we will pass that in when we create the object to DHT object. And this is just some stuff that came from the OLED display. And this is defining the OLED display, this is defining the real-time clock. We have some temporary, in my case, user ID and password. We are going to be accessing pool.ntp.org for the time. This, of course, is for the United States. There is a European version. Can't quite remember what it is, but it's slightly different. Might have EU in it or something like that. If you look at Google it on the internet, you'll see. We are in Mountain Standard Time, so we are using an offset of -7 hours in seconds. That's 25,200, and the daylight time saving time hour is 1 hour offset, which is 3,600 seconds. And we create a little structure for the time information, and we will also create another structure for the display time. We'll get the date and the 12-hour time and the 24-hour time, or sometimes called military time in the US. And we will, in the setup, we just set up the OLED display. We've gone through that before. We set up the wire thing because we have to enable the I2C bus or IIC bus. And we will start the Wi-Fi, and while we are if we're waiting more than 30 seconds or 15 seconds, I think it is in this case, then we do a Wi-Fi timeout. If you got a poor Wi-Fi, you might have to increase that to maybe 60 or something. Then we are configuring the time. We're giving it the GMT offset, the daylight offset, and the NTP server name. Then we get the local time into the time info variable. We then disconnect the Wi-Fi, we don't need it anymore. And then we are setting the year, month, day, hour, minute, and second in the clock, real-time clock, and we clear the display, and that's it for the setup. Then we have one little function here to get the display time, and so we're actually just formatting it with sprintf commands. date time, 12-hour time, and 24-hour time. And for some reason, it looks like the months are actually, the numeric months go from 0 to 11 perhaps or something, but so we are therefore incrementing it by 1 for the display. And of course the year is like they call it an epoch, based on an epoch, and 0 means 1st of January 1900, so therefore you have to add 1900 to it to display it. So that year value right now is 124 instead of 2024. I think that's a leftover from Unix and Linux. They have that sort of time. In any case, then in the main loop over here, we are just every second, we're delaying a second, we actually read the temperature and humidity. We get the time, then we get the display time, and we will simply just display it on the OLED module with print and print line statements, and that's it. It is pretty simple. Now, next we're going to be looking at how you would implement something similar without a real-time clock chip and with a standard ESP32 module, and you will find we're using a TFT display, and you'll see it is way more complex when you don't have the real-time clock chip, and the display, the TFT display, is an ISP display. It's much more complex to use. Anyway, so that is it for that version. Now we can turn it off, and we're going to disconnect this module here, put that aside, and now we're going to bring in this thing over here, and we will make some adjustments in order to emulate this Grove connector thing. You don't need to do anything else but to find, in this case, to find some suitable pins for I2C and feed them into the plug, and then they will plug straight into the socket. So there's nothing really magic about these Grove connectors, other than they're good for beginners, because you can't accidentally, you know, if you got them on a board like this, you can't accidentally connect things back to front and do damage to components and stuff. In any case, and you know, it's convenient. Okay, so that is one thing. Now I have got these displays here. They are identified on the LCD wiki, which is where you look for information on them. So if you go there, this is the lcdwiki.com, and if you do a search on 3.2-inch IPS SPI modules and so on, you'll come across this one, and this is actually the one that it is, and it has descriptions there. And because when you buy these things from China, they have absolutely no information with them, so you have to find it yourself, and this is a very convenient place to get it. And it tells you, for instance, you know, it's the ILI 9341, and interface is 4-line SPI, and so on and so on. And it has all sorts of, we got the one with the touch screen. That's the way it looks underneath. It has an SD card adapter as well, which also we won't be using in this software right now. And it tells you what these pins on that port that we're using, what they are. So if you're interested, you can read that. All that information will be in the description, of course, including to a link to the software that you're looking at and so on, so you can play to your heart's content. In any case, that's where that information came from. Now, if you go to the I put comments in the place here. This is the website we were just looking at, and this is where you can get information on the starter kit, and these are how I connected the pins to that particular chip. But of course, if you're using a different one, you feel free to connect it to different pins, of course. And the way that you do that, so let's go to Platform IO, INI. This is, of course, where the libraries are defined, and we are using the NTP client again, like before, and we're using the Bodmer TFT ESPI library for displaying data on the screen. There, I was using a library called FPAGO SP32 time, because we're not actually using the real-time. There is no real-time clock module on that module that we're using, so we have to use the built-in ESP32 timers and things for the timekeeping, and this is a library that allows you to do that, because as you're probably aware, the ESP32 has timers in it, and it has a function called millis, M-I-L-L-I-S, with little brackets. It gives you the number of milliseconds that have expired since it started running, and that of course means that you can, if you know the offset of if you know the time when it started, then you can always calculate what the current time is. So that's probably what this library does. I haven't gone into that detail on it, but in any case, it becomes a lot more complex when you have to do stuff in software, and of course this display is a great deal more complex than the simple little OLED display that's on the starter board as well, but it does show you that the starter board is really suitable especially if you're a beginner. It's much simpler to use, and you've got support and code on the Seeed Studio wiki and websites and GitHub and so on. Any case, now this Bodmer TFT library is a bit of a nuisance because it is very generic. It is meant to be working with any display you can imagine. You have to actually specify the characteristics of your current display that you have got hooked up, and then you normally do that by a user.setup.h file. Now this file is normally living in the Arduino library folder, and if you're in the Arduino IDE, you'd have to find out where your libraries folder is, and for some strange reason on my computer it is duplicated in 2 different places, and this had me fooled for a while some time ago when I first started looking into this. I would edit the setup.h file and nothing happened, and then I found out there was a second library folder with the same file in it, and when I added that one, then it did work. So I don't know how that happened and why that is. If some of you may know something about that, put it in the comments. It might help some other users. But in any case, that is one of the reasons I use Platform IO, because it is more powerful than the Arduino IDE, of course, much faster too, compiles not 3 times as fast and all that kind of stuff. But it can be a bit harder to use in some ways, and if you're just beginning in this stuff, it could confuse you a little bit, I guess, but you'll soon learn, of course, if you stick with it. In any case, it has a feature here which is really nice, that it has build flags, and you can put all sorts of information here, but in this case here, we're emulating what the user setup file does. This user setup file basically has a bunch of hash defines in there. So now we can actually emulate those here. So the first thing we do is, if you look at the user setup file, the first thing it does is, if it's already been compiled in, if you like, it sets user setup loaded is defined, and that tells it not to look at it multiple times, because there's multiple references in that library's source code. But so we can actually set it. So now that causes it not to look at the user setup file at all. It's going to bypass it every time. And then we do the defines on, okay, we're going to use an ILI 9341 driver. These are the pins, how it is pinned out. The backlight is on 5, and MISO, MOSI 17, 19, clock on 18, the select on 23, restart on 16, the data or command mode 15, and so on. Some fonts that we want loaded by default, and the frequency, and so on. It can all be defined in the build flag section. And now, if the library is updated, because normally in the Arduino IDE, quite often you see a message saying, oh, your libraries need updating. And then if it actually happens to update this Bodmer TFT library, it'll happily overwrite the user setup H file. And some people are saying, okay, we'll edit it and make a backup of it, so that next time if that happens, you can rename it back or something, but it's still a darn nuisance. And that's why when I'm using these kind of displays, I always go to Platform IO. I don't even bother with the Arduino IDE. Similarly though, in the Arduino and the Platform IO section, there is actually a clean operation that is used in order to, if you change something major, like the board type or something, you need to do a clean sometimes to make sure that the pre-compiled stuff doesn't get loaded in again that is not appropriate for that particular board or platform or whatever. So then also it would actually wipe out that user setup H file. In any case, you avoid all that by doing it this way. Alright, so next thing that I have done, and I think I explained that in another episode as well, this FBAgo ESP32 time library, I wanted to add something to the code to make some changes to it. And in order to do that, I went into the library folder and I got the ESP time H, and you see there's copyright by Felix Biego and so on. It's got these date functions and time functions in it, and I then was only two files there, the H file and the CPP file. Now when you have libraries, there's actually multiple files there. There's the definitions there with about other characteristics of the library that you don't need. You just grab the header file and the code file and you stick them in your own project here, and then you will comment out the library definition, and you are then in business, and you can make changes to your heart's content. And what you then also do is you put the include in quotes rather than in angle brackets, so it's actually looking in your local folders when you do that, so it bypasses the actual library with the same name. In any case, I did the same thing with the DHT, DHCH and DHT CPP. These originally came from Adafruit, but I also wanted to be able to make some changes to it, and they're in here. And TFT is something that I made up myself. I wanted to be able to have some simple functions to, for the display. It was a nuisance to use the low-level TFT functions. By putting those in here, I can now clear the screen. I can show a message in the center. I can show a message at the current cursor position. I can show it and go to the next line, etc., etc. Show text mode is for debugging. It allows you to, it'll display all the modes that it has, the colors, the fonts, the cursor position, and all sorts of information that you use for debugging. Anyway, so that's what we have. And getting back to the main CPP file here, much of this is the same as for the other module. So this is pretty much the same. Now note here that we have an ESP time as a real-time clock, and we're giving it the GMT offset, which is the -7 hours, because I am here in Mountain Standard Time. And that then means that later on, because we set up the TFT, which is different than before, we need the wire for the I2C bus, and that goes to Wi-Fi. That's now the difference here is that this config time method here. We in the previous module we gave it this offset, GMT offset, but here we're giving it 0 because we already specified it above here. So therefore, if I put it in here as well, we would end up with -14 hours instead of -7 hours for Mountain Standard Time. So that's why there's a 0 there. And for some reason, that library that uses the built-in timers and things in the ESP32, it actually comes back with an hour of 0 for midnight. Or 1 minute after midnight would be 00:00:0001 rather. So we want to display that as 12 AM, not as 00 AM. So I make an adjustment here. If the hour equals 0, then set it to 12. And just like the other one, the months appear to be 0 based. As far as I can tell, it seems to be coming back for 9 when it is supposed to be 10. So I just add 1 to it. Haven't checked into it any further than that. It does the same thing as before, creates string values that you can display. And then this is all the same as before, but now we are displaying it in 2 different columns. Second column is on offset 150 pixels and shows the date, time, temperature, humidity, and so on. So let's have a look how that works. Now, I've got this connected to my bench power supply, so I'm going to give it some power. And holds up the little antenna. There we go. So this is what it does. Similar to before, but now of course we've got a bigger display. We've got different colors. We've got some yellow and some green and some white there. Could have made it more colorful, could have made the background white, whatever. But it's working, and that is all we needed to know. So what do you do if you want to use some of these, some of that code in the Arduino IDE? Okay, so we'll go back to this, the simpler code here for this module that's running over there on the starter kit. And if you go into the Arduino IDE, I set a new sketch, gave it a name, and now I am going to be selecting the board. And we've got a Chao ESP32C3. Okay. Then if we go to, I've loaded the code in platform IO, and the first thing you'll notice is that we need this Ollie Krauss, and we need NTP client libraries. So we go to libraries. I have no idea what that 8G2, what that all means. I think that the guy that wrote this didn't necessarily use very good names for his stuff, but in any case, so that one is installed, and the next thing that we need is NTP client. Actually, I should be able to copy that from here and then paste it in here, shouldn't I? Except it included. the unnecessary little slash there that we'll remove. Yeah, that's the one. Okay, install. Alright, so now we've got the libraries, and now we can go into Platform IO, and we'll go to the main folder, and we can go control, oh, wrong button, Control A, Control C, and we can go to here, Control A, delete, Control V to paste. Alright, so now we need to also import some of those other files. Show sketch folder, that's what I want. So now I can go to the folder where I am storing these header files. I can copy those, and I can go to that's not what I wanted to do. I can then paste those in here. I can then go back to this folder here. Now I want the source folder, and I want this one, and I want this one. Copy. And paste. Okay, so now we have those files, the supporting files that we need, and we can go like that. Let's get rid of this. All right, so what else do we need to do? Let's have a look. The only thing we'll do is we don't need that Arduino thing at the top, although I don't think it does any harm, but does it compile? Okay, now these are warnings, and they are coming from the PCF 8563. That was a okay. It's done to compile. It's actually a successful compile. These things are only warnings. They also show up in the platform IO, but you can ignore those. This code was written obviously at a time when for a more permissive C++ compiler, and they have made changes to it with version 2, I think, of the Arduino IDE, and they're doing a little bit more error checking. But yeah, so this is it. It's compiled, and you could upload it to the device, but the code is already in there, so I'm not going to bother to do that. I just wanted to show how relatively simple it is to actually port. When I'm doing stuff in Platform IO, you can port it to the Arduino IDE if you like. So I think that's it for this particular episode. We've got some stuff coming up. We're going to be using some modules here that didn't come with the starter kit, like this RFID stuff. And so we've got more stuff coming, and I hope to see you guys there in those episodes. Make sure you are liking, subscribing, and clicking the notification thing so that when the new episodes come, you will know about it and you can have a look at them. All right, so that is what we have for today. and I'll see you guys later.